So hello guys, today we are going to solve a leetcode question, that is leetcode daily question. What is the question says? What the question title is least number of unique integers after k removals. The question number is 1481. What is the question title? Least number of unique integers after k removals. So first we'll start by reading the problem statement. And then we'll go further. Okay. So what does my problem statement says? Given an array of integers a are r and an integer k. Okay. First we'll read the first line. So you are given an integer named arr and you are given an integer k. Okay. Array of integers arr of name arr and integer k. Find the least number of unique integers after removing exactly k elements. Find the least number of unique integers after removing exactly k elements. So from the array, you have to remove some k elements such that the number of unique integers, in the array are the least. That means if my array consists of only ones, so what are the number of unique elements? May it be of size 10 raised to power 5, but all elements are 1. So it contains only one unique element, that is 1. Agree, right? If my array is of size 10,000, okay? If my array is size 10,000, but all the elements are 1. So how many unique elements are there? How many unique elements are there? How many unique elements are there? There is only one unique element. Okay. But bhaiya, what are unique elements? Oh, so I don't know what are unique elements. Okay, it's okay. I'll tell you. Okay. Suppose this is my array. And if I say that what are unique elements? Those elements like 1, 2, 3 are all unique by themselves. Unique means they are not same. So if it is saying that number of distinct elements, they have just formed name that unique, but unique basically means distinct elements. So you have to minimize. What is the task in hand? You have to minimize. Now I will just rewrite the question in a very easy way. You have to remove some k elements from the array such that the number of unique integers becomes such that the number of unique integers, I am using the term unique here, it definitely means number of distinct integers becomes less, the most less possible, like the minimum number possible becomes the minimum number possible. So if that array consists of all the same elements, then my unique integers are only one unique integer. But if my array consists of these like 1, 2, 3, it consists of three unique elements. Okay, three distinct elements. 1, 2 and 3 are not equal to each other, hence they are distinct. So you are said that you have to remove these distinct elements. Okay, you have to remove these distinct elements. You have to remove the distinct elements from this array. Distinct elements, if you are given k2, and k2 means you can just remove two elements from the array. Two distinct elements from the array. So two distinct element means, what does two distinct element means? That I can remove this and I can remove this, so only one remains in my array. Unique integers will be, number of unique integers will be 1. Unique integers will be 1, not the number 1, not this, not the array element. No, the size that only 1 is present. Maybe if this is the case, 1 1 2 3. Okay, so what are the distinct elements here? 1 2 and 3. 1 2 and 3. Okay, suppose if I take this case, now I am going deep. Okay, I'm going deep. 1 1 2 3. Okay, suppose if I say that what are the distinct elements present. So 1 2 3 are my distinct elements. 1 2 3 are my distinct elements. Okay, and I am given k is equal to 2. I am given k is equal to 2. You have to minimize the number of distinct elements. You have to minimize the number of distinct elements in two moves. In two moves. Okay, so if I say that I'll just simply traverse and try to remove. Okay, I'll try to remove. So if I remove one, is it gonna decrease the number of distinct elements? Is it gonna decrease the number of distinct elements? No, this is not gonna decrease the distinct elements. Okay, removing this because one more one exists here. So 1 to 3 would still remain. 1 to 3 would still remain. Okay, not a point of removing this also. I can remove this. I can remove this because if I remove this, the number of distinct elements became only 2. Becomes only 2 elements. 2 elements exist in the array. Exist. Only 2 elements exist. So and I have used my one move, so it becomes 1. It becomes 1. And on the next move, I'll remove this. I'll remove this. So my k becomes 0. I have used both my moves and my array contains only one element. My array contains only one element. Okay, that seems to be nice. So what I can see the inference from that is, the inference that I will, if I try to remove the elements, if I try to remove the elements with lowest frequency first, first, then the resulting array would contain the least number of elements, least number of distinct elements. Why I am saying this? I'll just tell you. I'll simply tell you. Just wait. Okay. Suppose if I take this example 554, and k is equal to 1. K is equal to 1. Okay. If I tell you to map them in a map, okay, I'll tell you to store them in a map like its frequency, the number with its frequency, okay, number with its frequency, because I want to know the frequency. Why want to know the frequency? So that I could get a rough estimate. That how many distinct elements are present, because as you know, the key value can only be a distinct number, can only be a unique number. So my map helps me to maintain the unique elements. Okay, so if I just iterate and store the frequency of each of the elements. So 5 is my 2 times and 4 is occurring one time. Okay, 4 is occurring one time. So I can say that my 5 occurs 2 times and 4 occurs one time. Okay, sure. So if I try to remove, as I said, if I try to remove with lowest frequency first, if I try to remove the element, suppose if I tell you what are the distinct elements here, as my map is storing two elements, so my number of distinct elements here is 2. So my number of distinct element here is 2. If I have only one move, and I have to eliminate a element. I have to eliminate the element fully, because if this array doesn't contain any 4 or doesn't contain any 5, then it is eliminated from that array. It is completely removed from the array. If it is completely removed, then my array only contains 4. That means it contains only one distinct element. So my problem is solved. Okay, for this case. So I just have to do, what I just have to do is, I'll just simply store it in a map. I'll just simply store it in a map. And I'll try to remove the element with the lowest frequency first. Lowest frequency first. Why lowest frequency first? Because as it is having the lowest frequency, it is easy to remove all the occurrences of that particular element. All the occurrences of that particular element. All the occurrences of that particular element. Okay, suppose I say that 1 1 1 1 1 and 2 2 is my array. Okay, you have to identify first the number of unique elements. So I have identified that the array contains only 1 and 2. What is the frequency of 1? 1 occurs 5 times and 2 occurs 2 times. Okay, so what is easy to remove here? What is easy to remove? Is it easy to remove 1 times, 5 times? No, no, right? Because my number of moves are limited. I have to save them. I have to save them. Okay, so I'll try to remove 2 because it is having lower frequency. Lower frequency. If I am able to make any frequency, if I am able to make any frequency of a particular number is 0, then it means that I have eliminated that element from the array. Eliminated that element from the array. Element from the array. Okay, so what is easy to remove? 2 is easy to remove. Obviously, if my k is 2, I'll just simply remove all the occurrences of 2 and what I get is only one element. Only one element. Okay, so in 2 moves, I can eliminate 2 2's and I'll get only one in my array. That is, my array contains now only one. That is the least number of unique elements the array can have. Okay, so if I try this test case, first test case 554. 554 k equal to 1. I have just one move. Okay, I have a map that stores the frequency. So 5 has a frequency of 2 and 4 has a frequency of 1. What I'll try to remove first. As I have only one move and I have to eliminate the maximum possible number of elements to 0. I have to make the frequency of maximum possible number elements to 0. That means that I have to make, like here, if I can make the frequency of 5 to 0 also, then it is fine. But I am having just one move. And I have to make the frequency of maximum element 0. Okay, to make the frequency of maximum element 0. So what is easy to remove? Obviously the number having my least frequency is easy to remove. So I'll just simply remove 4. That means I'll reduce its frequency. So if it becomes equal to 0, if its frequency equal to 0, I'll not count it for my result. Okay, so if I see how many unique elements are there with greater than 0 frequency, that means it occurs one or more than one times. So only 5 occurs. If I remove this 4, only 5 occurs in my array. So number of distinct integers that occurs in my array is 1. Okay. So what would be the priority? In what priority I will remove the elements? In what priority I'll remove? My priority is going to be the frequency of elements. Frequency of elements. In what order? Lowest to highest. Why lowest? Because the lowest one is easy to remove. Obviously, someone with very less strength is easy to knock down, right? And someone with very high strength, like 6 feet tall and something, is very difficult to knock down. So I'll knock all the ones that are having lesser strength. As I am having only 4 punches, suppose K is the number of punches that you can punch in a face, okay, in a person's face. So you will try to, and you have to maximize the number of knocks, okay. So what you will try to do is you will try to knock all the people that has low strength, right? So strength here means frequency. So I'll try to knock down all the ones, all the all the elements that are having a frequency, that is having a low frequency. So I'll eliminate in the order of increasing frequencies, increasing frequencies. So if my array contains 1 1 1 2 3 3 3, okay, 1 1 1 2 2 3, and k is equal to 2, k is equal to 2. So if I try to store my frequency, 1 contains 2 times, 2 is 1 times, and 3 is 3 times. So what would be the priority? What would I remove first here? What would I remove first here? I can see that 2 has the lowest frequency. I'll try to remove this. In one move, I'll eliminate this. I'll eliminate this. I've used my one move. Thus my move is now lesser than the current value. One lesser than the current value. Okay. So now I have only one move. 2 is eliminated. So now my array contains only two distinct values. Now I am having only one move. What I can do is, these are having same frequencies. So I can choose any one of them and knock one element out of it. Knock one element out of it. But if but that element, as we can see, that element's frequency is not equal to 0, and element's frequency is not equal to 0, that means some other elements, if I try to knock this one also, if I try to knock this one also, so are all the ones eliminated? No, all the ones are not eliminated. So if all the ones are not eliminated, so my number of distinct elements still becomes 1 and 3, still are 1 and 3. Okay, so I'll consider a element as removed. I'll consider as an element as removed only when frequency of that element, only when frequency of that element becomes 0. Okay, okay. I'll try to explain it with the second test case. 4 3 1 1 3 3 2. 4 3 1 1 3 3 2. Okay, and k is equal to 2. Suppose I am storing the frequency of all the elements first. So I'll store 4's frequency. 4 is occurring one time. 3 is occurring 3 times. 3. 1 is occurring 2 times. And 2 is occurring one time. Okay. And I have only 2 punches. Okay. I can knock down only 2 people. 2 people. I want the same type of people to stay in my array, and I don't want any dissimilarities. I want to minimize the dissimilarities. Okay. So what should be my priority? Those whose strength is less, I'll try to eliminate them. So I'll try to eliminate 4. I'll try to eliminate 4 because it has the lowest frequency. Okay, I'll eliminate 4. So my elements 4 frequency becomes 0. 4's frequency becomes 0. Okay. And what should be now my array contains only 3 elements. I have come down from 4 to 3. Now I am using one more punch, and what would be my priority? The least strength one. Okay. So I remove 2 also. So now my array contains 2 elements, 2 unique elements. Okay, so I have successfully removed, like I have removed this 2 also. So now my array consists of only this, So the number of unique elements in this are only 1 and 3. Okay, so in 2 moves I have reduced it to the lowest number possible. If I am not using this algorithm, I would have removed any of ones or threes, and my number of distinct integers would not decrease. Okay, so my target should be the lowest frequencies. Okay. But But what if I tell you, see, suppose I am traversing the array, I'm traversing the map every time, I'm traversing the map every time I remove something. Okay. Every time I remove something, I just check. Okay. I just check. This can be one solution. This can be one solution to this problem. Okay. I'll just store all the frequencies. I'll store all the frequencies and I will knock down. I will knock down the lowest frequencies first. Lowest frequencies first. But here's a catch. Here's a catch. What is the catch? How would you determine the lowest frequencies? I have told you that you can remove the lowest frequencies, but suppose if this is my array k is equal to 1 and I have this 5 equal to 2, 4 1, how would I determine what is my lowest frequency? How would I determine that one is the lowest one present in this? One is the lowest one present in this. What I'll try to do is, if I store them in an array, if I store them in an array, if I store all the frequencies in an array, okay, if I store all the frequencies in an array, like here I store 2 and 1, here I store 2 and 1. So I can easily sort this array, and I can get my frequencies in the increasing order. I can get my frequencies in the increasing order. It is not mattering whether you are checking the element that you are removing. You don't have to return the list of elements that you are removing. So there is no need of any other map. Okay. Suppose you could make a multi-map. You could make a multi-map in this case and store the frequencies with the elements. Okay, and you could just simply return the element also that you are removing fully. Okay, so if this is the case 1 1 2 3 and my k is equal to 2 and my k is equal to 2, suppose 1 occurs 2 times, 2 occurs 1 times and 3 occurs 1 times. Okay, so if I try to store this, if I try to store this frequencies in my array, it is getting stored by this 2 1 and 1. Okay, and if I try to sort them, I'll get it by 1 1 and 2. I'll get it by 1 1 and 2. This makes my work easy. How? I don't have to traverse it all the time to get the lowest element, to get the lowest frequency. My array is storing all the frequencies already. My array is storing all the frequencies in the sorted order only. So what I'll do now is I'll just pick up, like this is my sorted array 1 1 2, my k is equal to 2. I'll just pick up the first element, and I'll reduce the k by its value. So if my frequency is 1, I'll remove 2 by 1, 2 minus 1. I'll remove it by 1, and as it becomes 1, I'll make it 0, or you don't have to make it 0. Okay, you just simply remove it, okay, but you still have one more move remaining. Okay, so you are simply removing a one. You consider that you have removed this array, you have removed this element, so you are decreasing your value. By how many elements? Suppose this is only one, this is occurring only one time, so I remove by only one. Okay, so my k becomes 1. I come to the second element. What I try to do is I'll again try to decrease my k value by the nums element, because this is the frequencies that I am storing. So if I try to remove the frequencies, that is, if it is 1, that is, if 4 has a frequency of 1, that is, it is present only one time. If 5 has a frequency of 2, that is, it is present 2 times. So my k is getting reduced by this value. That means that I am using one move to punch this man. Now I am using one move to punch a different man of the same kind, of the same similarities. that is of the same number. Okay, so I'll decrease my k with the value of nums that is present here. The value of nums that is present here. Okay, so if I try this for this test case, 4311332. 4311332. Okay, and what I'll first do is, my first step is to store the frequencies. Okay, I'll try to store the frequencies. My k is equal to 3. Okay, my k is equal to 3. Okay, my k is equal to 3. So I'll store the frequencies. I'll store 4 first. 4 has a count of 1. 3 has a count of 3. 1 has a count of 2, and 2 has a count of 1. Okay, so now I want to determine, I just stored it by traversing the array. Okay, you can see that 3 occurs 3 times, 1 occurs 2 times, and 2 occurs only 1 time. That is what I have stored here. Now if I want to sort them in a increasing order, I have to store them in an array. I have to store all the frequencies in an array. If I store them in an array, it's stored like this. It is stored like this because I come to the first element, I store it on the first index, then I'll move forward. I come to the second element, I store it on the second index, and I move forward. If I come to the third element and I store it on the third index, I'll move forward. I come to the fourth element, I store it on the fourth index, I'll move forward. So this is what my array will look after the traversal. Okay, but I wanted to get the sorted way. I wanted to get the sorted order. This is some random order that was stored in my map. So I'll just sort this array. If I sort this array, what I get is 1 1 2 3. Nice. I am having a count of 3. I have only 3 moves. Okay, I am having k value equal to 3, and I have to remove some elements. I have to remove this element. Just remember that every index in this element contains a different number. Suppose this is map for A, this is map for B, this is map for C, this is map for D. So number of unique elements in this array is the size of this array currently. That means that A is occurring one time, B is occurring one time, C is occurring 2 times, and D is occurring 3 times in the array. That means B, A, B, C, C, D, D, D. That is some sort of my array that I have represented here. So I'll just traverse this array. What is my array? 1, 2. What was my array? 1, 1, 2, 3. 1, 1, 2, 3. 1, 1, 2, 3. And my k value is 3. I'll start traversing. Suppose this is my count that stores my answer. That stores my answer. Okay. That stores my answer. And this is the moves that you can make. This is the moves that I can make. Okay. So I move to the first element. Suppose it is A. And A is occurring only one time. So what I say to K is, there's only one man standing that has the lowest frequency of 1. I'll punch that man. So this is neglected, and my frequency, my number of moves are reduced by 1. So my number of moves is reduced by 1. My count would not increase. Why my count would not increase? Count is my number of distinct elements. Why my count would not increase? Because my k value is still on. I can still remove this element. I have removed one element. I have removed only one element till now. Okay, I have still moves remaining. I'll just move to the second element. My k value is 2 currently. I'll move to the second element. I'll remove k by b times into its frequency. Okay, so I'll remove 2 by 1 because it occurs only one time. I'll remove it by 1. Okay, I'll remove it by 1. Now my k equal to 1. K is equal to 1. Okay. I'll move forward. Suppose this is my C and I have only one move to make, whereas I have two occurrences of C. Two occurrences of C. Okay. Two occurrences of C. So I'll just decrease it by 1. Suppose if I decrease it by 1, or if I decrease my k value by number of time by nums, so k minus 2, that is 1 minus 2 is equal to minus 1. If that number has become negative, that means I'm overusing my moves. To remove one or more than one element. Okay, suppose if this was 1, my k would have exactly been 0. Okay, and there was no sort of problem. But if I am removing an extra element, that means it was not possible, it was beyond my range. So I'll count this also as my answer. Now my count increases because I am out of my moves. K has become less than 0. I'm out of my moves, so I'll increase. I will not decrease k now because my k, the number of moves, the number of man I can punch it, is become equal to 0. So on this element my count increases, and as I traverse on this element my count increases. So my count becomes 2. That means my array consists of only two elements. That are unique. Okay. If I try this on this example, 441, okay, and k is equal to 1. I'll just try to make a map. 5, 2 and 4 occurs one time. I'll store it in an array and I'll sort it. Suppose I have sorted it, okay, and I'll try to decrease my k value. With my answer of I. What is my answer? Answer is my this vector, the answer of I. So my k minus 1 equal to, like, 1 minus 1 equal to 0. Right? 1 minus 1 equal to 0. So I have successfully removed this element. I will not count this element. I'll not increase my count for this case. Why? Because I have removed this element. I have not fallen short of the moves. I was in moves and I have successfully removed this element. Okay, if this was 2, and I had to, if this was 2, so that means that 1 minus 2 is equal to minus 1. If my minus 1 is there, that means I have accidentally knocked out two elements. So that second element was not meant to be knocked out. So I'll count that element also. As my distinct element, because that element is not knocked out and is knocked out by mistake. So I'll include this as my distinct element in my distinct element list. As soon as my k value becomes less than 0, I'll simply add it. I'll simply increase my count from that number. I'll simply increase my count, because any other number decreasing still remains my k less than 0. My k values, my moves are finished. I can't remove any more elements. So the remaining size of the array becomes my answer. Okay. If I try to summarize what I'm trying to do, I'm storing the frequencies. I am storing the frequencies in the array. I'm storing the key value pair. Then I'm storing the frequencies in an array in a sorted form. And then I am reducing my k value by the answer of I value. Okay. So if this is 1, I'll reduce it by 1. This is 1, I'll reduce it by 1 again. Okay, and when my k becomes less than 0, I'll increase my count. Why? Because that means I am out of my moves, and now any element cannot be knocked out. Till it is greater than 0 or equal to 0, my elements can be knocked out. Okay, so if I try to write the code for this, first I'll try to make a map. I'll store all the elements in my map. Okay, I'll declare an answer vector. Now I have all the key and the values. I'll declare my answer vector. I'll traverse the map. And I'll push all the frequencies. I'll push all the frequencies into my map. Into my array, and then I'll sort my array. As I have sorted my array, now I know that what element is to be removed. Okay, so I will traverse my answer array. Now I know what elements are to be removed. If my k is greater than equal to 0, I can simply remove it. And if my k is less than 0, I have to increase my count. What is my count? Count is the number of distinct elements still present in the array, and I'll return my count. If I try to run it, okay, count equal to 0. Okay, it's successfully run. Okay, I try to submit. Okay, submitted. So this was all about question. What I've tried to, if I try to summarize what I did, I just made a map. I mapped all the frequencies. I stored them in a sorted order in the array. I've stored them in a sorted order in the array. If my k value is greater than or equal to 0, then I would reduce my k value by the answer of I value. Else, if my k value is less than 0, that means that I have overused my moves, and there is no more move to go. So that element I have decreased, I'll count that also. So my count would increase from that case. That my k value becomes less than 0 on that number only. That's why I'm putting this on the second line. Because if on that index my value becomes 0, I'll count that index also, because that number is now existing now. If I'm not able to make my k, if I'm not able to fully remove that element, I'm out of my moves. So I cannot decrease it. I'll still have to count it. If I talk about the time complexity, I'm just using a simple map extra and a vector of array. So my my space complexity is O of 2 into n. And what about my time complexity? As I'm traversing only once, but I'm sorting the array. So maximum frequency would somewhere remain O of log n, because if all the distinct elements are there, if all the distinct frequencies are there, so maximum frequencies can be n log n, right? So time complexity would be n log n in this case. So this was the solution of my question: least number of unique digits after k removals. If you have any doubts, you can comment it in the comment. You can say it in the comments, and if you have any suggestions, you can say it in the comments. Okay. If you like the solution, do share, subscribe. Okay. Thank you. Have a good day. Bye bye.